June 16, paper is 51. Lithium is a soft metal which may be cut with a knife. It is usually stored under oil because it reacts rapidly with moisture and oxygen in air. Lithium is corrosive and may cause burn. Lithium is highly flammable and a large amount react violently with water. Lithium, these are the safety precautions. Lithium with water gives lithium hydroxide and hydrogen gas. The release of hydrogen gas is a very clear symptom that this reaction is very dangerous. The reaction can be used to determine the relative atomic mass of lithium by measuring the volume of hydrogen produced from a small amount of lithium. So read the question. Label the chemicals in your diagram and show how the reactants can be kept apart until the reaction is started. So should we use
Gas syringe.
Gas syringe is fine. And he says keep them separated. Should I use a bung in it? A two-hole bung?
Yes.
Then how to separate them, the reactants?
Is the black part water?
This is a good point. I was thinking that we can put, we want to react lithium and water now. So we can put lithium in the bottom and we could put water because we can't keep them together in the start. To successfully carry out this experiment, a correct procedure must be followed. The lithium you will use is stored as large pieces under oil. As large pieces under oil, beginning with a large piece of lithium being removed from the oil. State how you would prepare a small piece of lithium for use in this experiment. So we should cut it because he already explained that lithium is cuttable by a knife.
Yes.
But should I cut it outside?
No, it should be under the oil.
Yes, good. Put it in the flask. So how we know reaction is complete?
When the gas has stopped.
The piston, na?
Yeah.
Reaction experiment proceeds safely. Examiner says lithium is corrosive and may cause burn. Highly flammable.
So if it's highly flammable, it shouldn't be kept around the solvents that can.
Catch fire.
Yeah.
So should I wear gloves?
Yes.
Second one, that keep away any keep away any flammables.
Yes.
The relative atomic mass of lithium is known to be approximately 7. So should I use the equation?
Yeah.
So first we find the number of moles of lithium.
This will be 0.014.
So if we go for moles, so now can you help me? What should I do? Should I half it?
Yes. So it will be 7.15.
Are you converting in a scientific notation?
Yeah.
7.15
times 10 to the power of minus 3.
minus
3. The final answer is 0.172.
0.172 dm cube.
Yes. They didn't mention the unit, so we can put it in any form, right?
I think the same, because they have not mentioned it. Cm cube is a common unit, but we can leave because he has not mentioned it. What would be the capacity of the gas collecting apparatus you would use for the volume of hydrogen produced in part 4? This is a tricky one because syringes are normally in cc. So, now here some memory should be there because syringes are not available in every size. Common sizes of syringes are 25 cc, 250 cc, 500 cc. So what should I take?
Isn't the 172 centimeter cube the answer?
No, but then we can't take exact of the same size. Na? That will be a problem because how it will expand then?
Oh,
Because you need some air also. Na? The air will also be there. So you need some space for air, any expansion of gas.
so you can take 250.
250 is fine. Because you need to give some space for air.
Yes.
You need to give some space for air, for expansion of gases, or maybe some byproduct also form in form of gas.
Okay.
Another method that can be used to determine the relative atomic mass of lithium is by titration of the lithium hydroxide produced during the reaction with water. The following experimental procedure may be used. Add 100 cm cube of distilled water to a clean beaker. Add a known mass of lithium to the distilled water. After the reaction is complete, transfer 25 cm cube of the solution. After the reaction is complete, transfer 25 cm cube of the solution of lithium hydroxide from the beaker to a clean conical flask. Titrate this with an acid of known concentration. So is he using the benefit of lithium hydroxide being a base, a good base, alkali?
Yes.
So that is why he's trying to do acid-base titration. How you would accurately measure the total volume of distilled water in step 1, 100 cm cube. It's a big volume. So should I take cylinder?
Yes.
Or if I need more precise, I can use a cylinder. 100 cm cube, 100 ml. So I can use, I can also use a burette.
Yes.
For burette, I can opening the tap of the burette, I can accurately transfer the 100 cm cube.
Yes.
State how you would know that the reaction between lithium and distilled water was complete. Bubble stops and
Yes.
no gas effervescence. So no bubble seen. Also, all of the lithium will disappear because lithium is converting into a soluble liquid.
Yes.
State how you would transfer 25 cc is a very famous question. Should I go for that all-time famous component pipette?
Yes. Okay.
25 cc. State how you would ensure that your titration results were reliable. That's a famous physics question. In order to, we should
Yeah.
repeat the reading.
Yes. Can
So
we
should
say we can plot a graph?
no, graph is too long because we should go for the lab work now.
Yeah. Okay.
Do you remember in O-level chemistry, it was a famous question like if I repeat the trial 3 times, then how I know that which one is the better reading?
Calculate the average.
No. The two close readings. We need to mark two close readings. If 2 to 3 readings are close, it means the titration results are reliable.
Yes. Okay.
Repeat the trial I think it is better if I use the word, sorry for the physics, which I should use repeat the if few readings come very close, it means that the results are reliable. To make
Yes.
sure that the beaker and the conical flask used in the experimental procedure in C are clean, a student decide to wash them out with some distilled water before starting the experiment. Some water remains in the beaker. State the effect, if any, this would have on the calculated relative atomic mass of lithium. Some water is remaining. So it will dilute the system because water is there. It's not dry.
Yes, so the mass will increase.
So one thing is there, water is there. Now what will happen?
The mass should increase.
Why? That's fine. That solution is diluted. Reaction would be slow. But how come solution is dilute only? Because we are just adding water. Reaction would be slow. But how come AR will change? Number of moles are not changing. Some water remains in the conical flask. State the effect, and this would have on the calculated. Then what was that? Relative atomic mass. No, there's a confusion now. Just a minute. These are very close questions. Oh, beaker and the conical flask. And actually, he is rinsing both of them with water, with some distilled water before. Some water remains in the beaker. Now there's a problem. There's a problem because it's here is talking about beaker. I thought it's talking about the flask, the titration flask. Then it's a mistake that he's talking about in this part. He's talking about the beaker. In the beaker, if water remains solution, excess water will dilute the solution. So that was you were right. AR will increase because this water is actually reacting with lithium. this water is reacting with lithium. So there is more water, more lithium will be used up.
Yes.
This water is reacting with lithium. This water is reacting with lithium. Some water remains in the conical flask. State the effect, if any, this would have on the, this is about flask now.
Yes.
Actually, from the titration system, they are withdrawing 25 cc and putting it in a conical flask. If the conical flask is containing some water already, it will be diluted. It will be a bit slow in speed, but there will be no change on relative atomic mass of lithium because it's simply change because moles are not changing.
Okay.
Activation energy is the minimum energy with which particle must collide so that a reaction occurs. The activation energy for the reaction of magnesium with aqueous hydrogen ions can be determined in the laboratory. Mg plus H plus, Mg2 plus H2. A magnesium strip is placed in dilute HCl and the time taken in seconds for the magnesium to disappear is measured. The initial rate of the reaction is calculated as 1 upon T. If the experiment is repeated at several different temperatures, then the following mathematical relationship can be used to calculate EA. T is the temperature, 1 upon T is the initial rate. Graph of 1 upon T against can be plotted. It says 25 cm cube of dilute HCl is added to a boiling tube. The boiling tube is placed in a water bath until the dilute HCl reaches a constant temperature. This temperature is recorded. A magnesium strip of mass 0.10 gram is added to the boiling tube. The mixture stirred and the time taken for the magnesium to disappear is recorded. The temperature of the water bath is changed and the experiment is repeated. The results of the experiment carried out at different temperature are recorded in the table below. Process the results to calculate the reciprocal of temperature and log base 10 1 upon T. The first value of 1 upon T has been done for you. Record 1 upon T in standard form to 3 sig fig. Log 10 1 upon T to 2 dp. You should expect log 10 1 upon T to be negative. So first we should fill the column 1 upon T. Okay, I'm just coming. You fill the column. I'm just coming.
Okay.
Now 1 upon t. Have you filled the column?
Yeah, I filled the first column.
Can you tell me also?
Yeah. 3.41 times 10 to the power of minus 3.
3.41 10 power minus 3.
3.33 times 10 to the power of minus 3. 3.30 times 10 to the power of minus 3. 3.26 times 10 to the power of minus 3. 3.22 times 10 to the power of minus 3. 3.20 times 10 to the power of minus 3. 3.16 times 10 to the power of minus 3. 3.12 times 10 to the power of minus 3. And 3.05 times 10 to the power of minus 3.
1.20 1 upon. Then you have to take log of all of them. So should we expect all the 10 powers will go with a negative 2 into, just like the first answer will be minus 2.40?
1 second. The first answer is minus 1.92.
Second,
It's minus 1.76. Minus 1.55. Actually, it should be minus 1.56, sorry.
1.56.
Minus 1.45. Minus 1.25. Minus 1.28. Minus 1.18. Minus 1.08. Minus 0.95. And minus 0.90.
Not a cross. This is log 1 upon t. Okay. So 1 upon 3.47 and 1.20. 3.4. 3.47.
Yes.
And what is with it? Minus
Minus 1.92.
minus 1.92. Here it is coming like this. It's a big exercise. 3.41 10 power minus 3. And it is 3.1, 3.41, and it is minus 1.76.
Yes.
Oh, I think first one, I think I marked first one wrong, 1.76. One point seven six.
Yes.
The first one I marked wrong. It's 1.92. It's not 1.19. It's 1.92. Let me repair it. It's 1 point. I don't know why cross the dot marking dot is more accurate in such a minute graph
Mm.
because cross always slightly overwrite. Anyways, now 2 points are plotted and then 3.33. Minus 1.56. Then 3.30 and 1.45. 3.30, 3.30 and 1.4, 1.4, 1.4. 3.26 and 1.25.
Yes.
Okay, then it is 3.26 and 1.25. 3.26. With 3.26, how much it is? 3.26 and
3.26 and 1.25.
1.25. 3.22 and 1.28.
1.18.
Hmm?
Yeah, sorry.
3.22 and 1.28. It's a big job. 3.22 and 1.28. What type of line is coming? He says line of best fit. The points are
Yeah.
coming. 3.20 and 1.18. 3.20. Oh, 1.18. 3.16 and 1.08. 3.16 and 1.08. 3.16. 1.08. 3.16 and 1.08. Three point one two. 3.12 and 0.95. 3.12. Are you done with the graph?
Yeah, I have 1 point left.
Okay. 3.05 and 0.90. 3.05. 3.05 and 0.9. 'It's a very scattered line. I don't know what. Maybe one of the. I'm getting a line like this.
Me too.
On your graph, circle the 2 points you consider to be the most anomalous. Label each one with a different letter. Explain what may cause each of the anomalies you have identified, giving a different reason each time. So we need to see the graph.
Yes. For me, the points I'm getting are, yeah, 3.05. And
Getting one, this one.
yeah, and the 3.12. Or
This
no,
one?
sorry. Yeah,
So these are the 2 points which are coming anomalous. X and Y. And what are the 2 points? Do you suggest 3.3, 10 power minus 3?
y
What
is y is 3.25.
No, one is 3 point, who is this X? 3.0. What is this?
3.005.
3.0 what? 3.05. Are you getting the same anomaly? This one?
Yes, I am.
And the second one,
It's 3.25. Oh,
and what is the Y coordinate?
I think it's minus, yeah, minus 1.25.
Determine the gradient of your graph. State the coordinates of both the points you use. So we can use any point. Ideally, we should not use the points which are already plotted, but definitely it's a feasibility available. I'm getting 3.1, 3.05. Okay, so what is this number? One is this number and second is 3.5. It should be it should be 3.52. Now see this one. So we can put the values in the gradient. Use your gradient from 1 and the mathematical relation on page 5 to calculate the activation energy. Copy this equation then. So now put the, if you can help to find the gradient, because
We should put the individual values of the coordinates.
actually, yes, we have to put the values in the gradient equation.
Um,
These are the 2 points now. I have this one, this point, and the other point. After finding the gradient, you're supposed to find the activation energy. Then he says, do you think the results are reliable? So what should we say that the deviation is less? Our best fit line is very precise. Not very much deviation. We can look at the degree of scatter is less. The majority points are around the best fit.
yes.
Student X commented that the data, but we should try to, let's okay, do one thing, we just stop here. And